Hi guys, Skylar here, and we're gonna get into the guided learning assignment 2 activity. This week we're gonna be focusing on kind of just some more basics of Python. Um, Let me get into the Jupyter Notebook first. Okay, so guided learning activity 2, programming fundamentals and NLP, which is believe it stands for natural language processing. Um, so I'm going to start by initializing the otter and the auto grader. So yeah, just once again, these are optional, but can be very helpful for kind of just reinforcing the concepts you see each week in your Math 108 classes, and just getting some extra reps programming and getting comfortable with Python and Jupyter Notebooks can be really helpful, especially if you've never really programmed before or even if you've never used Jupyter Notebooks. So yeah, let's get started. So for today, learning objectives, we're going to go over data types, which can be very important for like every piece of data has a type, and it can be something that's used to like debug your code if there's something wrong with it. You could break it into pieces and kind of if you once you figure out the types of data that you're dealing with, that can give you kind of a better idea of how to write the code, if that makes sense. So next, access the attributes and methods of an object. So more just intricacies of Python and kind of the data structures, compare and contrast lists and arrays, which are somewhat similar ways to store data in Python, but they have some key differences as well. And then kind of combining uh, some of those above objectives when we're going to use some methods uh, to clean some of the data in this case study we're going to be working on. Yeah, so using some methods to clean and standardize the data, um, perform text pre-processing tasks, including lowercasing and tokenization, using NLTK, which is that's like a library we're going to import that has a bunch more kind of more complex built-in functions. So we're just going to kind of touch on that, give you a brief overview, and kind of let you not code any of those, but just kind of show you how they work, just from an outside perspective. Uh, and one of those is called basic sentiment analysis. So we'll get into that a bit towards the end of the activity. So kicking it off, object-oriented programming is a kind of a central concept in Python. Um, so basically, everything can be described as an object, and every object has a data type, whether that's integer, which is written as int, a float, which is like a decimal, or like a number with a dot, um, str, which stands for string, which is like a text, which is written between quotations. Um, so objects bundle attributes, or yeah, I guess you could break down two subsets of objects, are attributes which is a bunch of data about the object we're talking about. And then there's methods, which define behaviors, which basically methods are like are functions that are embedded in the object, I guess, that you can apply to the object. And so the way we're gonna, well, we'll get to that. So I'm just gonna run this first cell, which is assigning the number 10, the integer 10, to the variable name and int, and the string data science written between quotations, which makes it a string, assigned to this variable right here called a string. Okay, so that brings us to the first task. This should probably just be a review of what you covered in class this week, but yeah, the question is, how can you check the data type of a variable in Python? So yeah, if you want, you can pause the video, give yourself a chance to just think about it or try some stuff. But I'm going to get into the answer now. So basically in Python, there's a function called type. So just to give you a quick example, I'm just going to write type and then parentheses. I'm going to do an int, and it's going to just return integer. When I do that with the other string, it's going to be a string. If I do type and then I put 10.5 just directly in, that's going to be a float because it has that decimal. So for this answer, I'm just going to put use the type function. Okay, now moving on, we're going to get into attributes. So yeah, they're kind of like variables within a variable, if that makes sense. And they're kind of, yeah, they hold information about the object. So I guess in this example, you have the number 10. It's essentially equal to 10 divided by 1. So the numerator is 10, denominator is 1. So this is an example of just calling an attribute. Python has some preset attributes here called numerator and denominator. And then the way you call these is you write the variable name that you're trying to pull the attribute from, I guess, kind of pull the information out of, and then you're going to put dot, and then you're going to type the name of the attribute. So in this case, we're looking for the numerator of this attribute. So this should come out to 10. And then same thing, denominator, and that's going to be 1. These are just 2 examples. There's a lot more attributes within these variables. And yeah, just kind of notice the notation and the syntax of how we're calling these attributes. Is we have the object reference, so in this case the variable name, and then the dot, which is how you let Python know you're performing some kind of action with this object, and then in this case, you have the attribute name after. So methods are some similar and different to attributes. Similar in that you call them in a similar way. You use the dot notation. But essentially they're functions that operate on the object in question. So we have, above we assigned the string data science to this variable named a string. So one of the other kind of built-in functions / methods in Python is this one called upper. And essentially this is how you run it. Similar notation, right? You have the variable name and then the function, or the function, the method after the dot. And so this one, as you can see, it just transforms the initial variable into uppercase, all uppercase. So one thing to note is you definitely, I mean, if you notice, there's these parenthesis signs just next to the method, after the method. So those are important in terms of syntax, and you need those to effectively run these this method. And then this is what happens if you don't have the parentheses. It's not going to return an error per se, but essentially it's gonna kind of bounce back and tell you this is a function, but it's not actually gonna apply the function to the variable in question. Okay. Okay, so little more on attributes and methods. So yeah, this is kind of what we call dot notation. So yeah, you have the variable name / object, you have a dot, and then you can have either an attribute or a method name to kind of either extract more data about this variable, or to apply like a function to it. So yeah, let's see. Yeah, so the attributes and the methods available for each variable is kind of based on the data type. Some objects could not even have any attributes or methods. So for example, like string only have string objects. So like text, essentially, in the quotations, those only have functions or methods associated with them. They don't have attributes. And yeah, so you can, Python documentation is one way you can kind of learn a bit more about some of this stuff. But another easy way to kind of figure out, what kind of functions or attributes are available to you is just a quick shortcut in Jupyter. So for example, you have a string, which is the variable you created, and then you're going to press the dot. And then if you press tab after that, it's going to show you a list of all the functions / methods that are available to add here. So there's a good amount, but if you notice, there are no attributes on this list, and that's because it's a string, and it's not an integer or a float, which would have some attributes available as well. So yeah, for example, could just oops. Okay. Um, all right. So the case study today is going to be involving customer reviews. We're all pretty familiar with them, Google Google reviews for a restaurant or product, on Amazon, on Yelp. They're all over the internet. Um, and so yeah, one way we can kind of analyze this data is by extracting the text reviews, and then seeing if we can kind of manipulate that data and draw any insights from that. Um, so one thing to note is that extracting this information can be challenging. It requires multiple steps. Um, and yeah, so one of those steps is data cleaning, which we're going to get into. But first, we're going to talk about natural language processing, also called NLP, which is it's kind of it's a field within computer science and AI that specifically is focused on the language aspect. So yeah, in relation to this, it's written reviews. It's not numerical data. At the origin of the data is not it's not numerical. It's like strings. It's language. It's a lot of this stuff that is kind of considered can be considered a little more nuanced than just like ones and zeros. And so what NLP does is it kind of combines like linguistics and the studies of language, with machine learning to kind of try and teach the computer how to analyze text and speech. So for example, like, chatbots, ChatGPT, um, translation services, Google Translate, and then sentiment analysis, which is something we're going to get into a little later in this activity. Those are all kind of examples of NLP. Um, and yeah, and it applies pretty much directly to customer reviews and what we're going to be doing right here. So um, yeah, so data cleaning is kind of a key step for most parts of data analysis, but particularly I think particularly with for like these reviews, for example, because they're text, because they're string, it's all string data, um, and it's text-based reviews. Um, Data cleaning kind of helps us um, kind of order and like standardize the data, um, organize it, and it helps us, yeah, extract more meaning from it. Kind of essentially, it organizes the data for the computer to kind of do the rest of the grunt work. So what does cleaning text-based data involve? So just a little example is if you see A plus, like imagine the computer's looking for, you tell the computer to look for A plus in a review, and that's one of the criteria we look for when we say, when we're trying to determine whether a review is positive or not. This association might not be as prevalent in other cultures. Maybe a lot of the world does not use like A B C D F grading structure, right? So NLP specialists work with computers to identify these cultural patterns and kind of leverage them in kind of when they design their models. And that's what we call domain knowledge, which essentially just means the computing power is an important part, but it doesn't mean anything without kind of understanding the context of the data, because otherwise the analysis, otherwise it's kind of meaningless. You need to be able to interpret and draw conclusions. So task number 2. We're gonna use some more methods on this first review. So this first line is essentially, it's assigning an example string, piece of string data here to the variable first review. And so what we're going to do is we're going to try to essentially make it into a lowercase function. So turn this whole text file into all lowercase. And you can pause the video here, take a second, do whatever you need to do. But I'm gonna just get into it now. Yeah, so basically you're gonna use, similar to one of the methods we used above, is we're going to, first off, we're gonna use the name of this variable we created right above to reference this text. And then we're gonna use a method called lower. And don't forget the parentheses. And then we're going to print it out just to show exactly, just to verify we got it right. And then we got, you check it, we got the same string, but it's all been converted to lowercase, which is just one of the ways we can kind of like standardize some of the data and clean it in essence. So why should you convert the text all to lowercase? One reason is if you're trying to analyze the data and say someone left a review like this that says great sandwich, both great and sandwich are capitalized, and you have exclamation point. And say there's tons of reviews and you're trying to kind of group some of them together, right, into categories. So say you're trying to group by the phrase great sandwich. But in this case, but say there's like, 20, 30 instances of that phrase, and like half of them are lowercase, and then another quarter have just the great part capitalized, and a bunch of, essentially they all have different, a lot of subsets of this data have different capitalization or spelling of this exact same phrase, essentially. So by putting it in lower cases, just one way we can start to standardize this, which kind of makes it easier for Python to count, which is one of the ways we can analyze this data is we can count how many times this phrase appears, right? But we can only do that if we standardize the data first, and by bringing it all into lowercase. Otherwise, it would be kind of, you'd get a bunch of different. These would fall into a bunch of different categories because they're not exactly the same, and Python's case sensitive. So task 3, we're going to use some more string methods. This time we got second review and third review variables. So we're going to do a similar thing. And yeah, we're just gonna put these two strings into lower. So yeah, let's get into it. Always, one thing also to keep in mind is if you're defining a variable above, then you always want to use it in the next lines of code if you're referencing that. For example, like I could just put in, if I wanted to, I could just put great sandwich dot lower, and it'd give me the same result. But the reason we're using these variable names is to make it easier and make the code more readable and scalable. So anytime something's defined up here, you want to reuse it down below. So I'm going to use second review and use that same method, lower, and same thing for the third review. And then, yeah, you see that looks okay. The same strings, just all lowercase. And yeah, AutoGrader agrees. So, okay, now we're gonna get into NumPy, which, yeah, NumPy is this, it's a package of Python code, slash like library that has a bunch more built-in functions that essentially help us kind of perform these operations on a lot more data at a time. So it's just something that kind of makes data analysis a lot easier at large scale quantities. Yeah, so within NumPy, there's a data type which is called, it's written as numpy.ndArray, but we're just going to refer to it as an array. You have already seen this in class, I believe, but yeah, arrays kind of just help us group data, similar data together, and makes it easier to apply operations and like perform arithmetic and calculations on it all at once. So first things first, we got to import NumPy since it's a library, external library. And we're just going to call it NP for short, which is pretty standard in the industry. And just to give you an idea, you can type NP right here and then dot and do that same thing. Press tab, and then we can kind of explore all the all the functions and everything kind of included within NumPy. And as you can see, there's tons of stuff that can help us, kind of get a more in-depth analysis of stuff. So yeah, a lot of stuff we're probably none of us will ever even use. Especially in this class, we're just going to focus on, a few of the more common and more useful functions. Kind of keep things manageable. All right, so task number 4. We have a built-in data type in Python called a list. All right. So just to review, yeah, a list it's kind of similar to an array in a lot of ways, but there is one major difference. And yeah, that's the question here. Feel free to pause the video, but I'm gonna just go through this answer real quick. So yeah, both lists and arrays, they're both sequenced data types is what it's known as. But the array, the main difference is the array requires that all its elements need to be the same data type. So just fill this out here. Both are sequenced data types, but arrays require all elements to be the same data type. Okay, so for example, I could just create a variable here called list example, and yeah, so lists, essentially the kind of the way to write them is they're within brackets. So list example, I could have like 400 text string hola and 4.2. And if I go to list example and type, it's going to say it's a list because it's in brackets. Yeah, whereas an array, this would all have to be numbers or all string or all float. But yeah, you can't have mixed data types like in the list. So yeah, you use bracket notation for the lists. Then to create an array, you can use the function np.array. And then to inputting input into that function, you use a list that creates an array of 3 strings or 3 numbers or whatever it is. In this class, we're just going to use the make array function, just slightly easier because I believe you don't have to input a list into that. You can skip the brackets when you use the make array function. So that's how we're going to do it in this class. It's a little bit simpler, but just something to be aware of. NP array it's a more standard kind of like industry-wide approach that people use. So next we're going to run this code cell to import the data science library, which includes the make array function I was just talking about. And yeah, and now we're on to task number 5. So the question is, the task is create a NumPy array called array reviews that contains the 3 previously assigned reviews, which were assigned to the variables first review, second review, and third review. And then below you have an example of how this should display. So this question's asking for us to use the np.array method instead of the make array. So we're going to do that, np.array. And in this method, we know, since we just mentioned it above, you need to input it in list form. So don't forget the brackets there. So we got first review, comma, second review, comma, third review. Close brackets, close the parentheses. Yeah, so that looks very similar to what we have above here. So that's a good sign. Another function in NumPy is called np.char.lower. And essentially what that does is it's kind of like the lower function that we used a few tasks ago, except it takes an array or a list as input, and it makes everything in that, it makes each element in that list or array lowercase. So side note on the structure of this is, notice there's 2 dots here. So you have to kind of think of it as like a hierarchy where you have NP, which is kind of the main library that you're referencing. Within that, you have a bunch of different modules, among them being char or char or char. And within that, you have a bunch of different functions as well. So for example, you have the lower function, you also have one that's called upper, and so on, just different ways to manipulate the text. So one way you can kind of just figure out or get more information about a function without going into the documentation is you can just write it out here and then have a question mark after, and it'll return, Python will return kind of the documentation for that function you're referencing here. So it kind of tells you what it does. It has the parameters. So A is essentially it's kind of just a placeholder variable for whatever you're going to put in the parentheses. And it's going to show you the data type of what the output is. And then it's got a few examples as well. There's a line right here that says call meth, short for method, string lower. So that's basically saying like it's kind of pulling back the curtains on that function and saying it's using the lower string method to each item individually, in each item in the array individually. So yeah, that's just something to do if you're getting an error. It can be useful to debug, or just if you want to learn more about what a given function does. Task 6. So we're going to use that function above, npchar lower, to the array of reviews that we just created. So it's just an example of how we can essentially manipulate the entire array, standardize it all by bringing it all lowercase, changing it all to lowercase at once, instead of doing that individually, element by element. So this is a faster way. So we have how we're going to do this is we are going to use that npchar lower function, and the input is what we're going to put in this parentheses, and that's going to be the array of reviews function, or a variable / array that we just created. And then, yeah, as you can see, it took that array of reviews and just transformed it into all lowercase text, which was what was intended. So now we're going to get into more of the analysis part of it, since that's kind of, you can see what we just did as kind of like the cleaning aspect. And now that the data is somewhat more clean, standardized, organized, we can start getting into the analysis a bit more. So another NumPy function is, this one's relating to strings. It's called np.strings.count. Somewhat similar to the Excel function count, if you've ever used Excel. Essentially, you're looking within an array for a specific bit of text, and you're going to try to figure out how many times this, whatever you're looking for, appeared within each item in the array. So in this example, you got np.strings.count, np.strings.count. You got the name of the array, and then you got what you're looking for. Which is in this case, we're looking for the word sandwich. But yeah, just a little behind the scenes is if you want to see or figure out how to run this command, or how to figure out like what arguments you need to enter and how many, you can go right here, just select after the parentheses, and then you hit Shift Tab, and it's going to have a little like sub window pop up. And you can see you have the two placeholders here. So A is an array-like data, or array-like argument, which we have our array here that we're trying to figure out how many times this string appears. And then you have sub, which if you go under parameters, you can see it's referring to the substring to search for. So that's just one way I personally I kind of use sometimes to better understand the function I'm using, or if I'm getting an error, figuring out if maybe I'm entering the wrong argument or something into a function. Anyways, we're going to run this, and it's going to give us an array of 1, 1, 1. And in that case, what that means is the word sandwich appears in each of the first 3 reviews one time. And then just to give you an idea of kind of the purpose that the cleaning served, if we run the same command, but we, instead of the clean data, we're giving it the array of kind of the raw array of reviews that was not changed into lowercase, you're going to get a different result. You're going to get 1, 0, 1, and that's because the second review, it had the word sandwich in it, but it was capitalized. And as we know, Python is case sensitive. So since you're looking for this lowercase sandwich, Python's not gonna detect a match there. And so, yeah, like using the clean data is better because we can identify everything that can identify the reviews that specifically address the sandwich. And then, if we have a next phase in the analysis, we can take all of those and kind of delve deeper. But if there's kind of a difference in capitalization or how it's written, some of those extra instances might kind of slip through the cracks, which in the end it kind of results in just slightly less significant or meaningful analysis and less significant conclusions. So task 7, we are going to create an array that's called great count per review array, or ARR for short. And the purpose of this is to count how many times the word great appears in each review. So similar to the task above, but now we're looking for the word great. And we're going to use the clean data array as input. So yeah, we're going to use array of reviews lower. And I'll just give you a second to think about that. Okay, so I'm going to use the same function as above, np.strings.count. And then we're going to use the clean data array. And then inputting what we're looking for is the word great in lowercase. And when we run it, we're going to get an array of 3 numbers that says 1, 1, 0. So essentially, just interpreting this real quick, is the first review had 1 instance of the word great, second review had 1, third review had 0. Okay, so seems good. So now we're going to get into a little more advanced topic, kind of just broach on it, give you an idea of like the next level of analysis here. And that's called tokenizing. So tokenizing is a process where we split these texts, these string files into smaller units, which we're calling tokens. The tokens can be They can be words, they can be phrases, they can even be sentences. That's all kind of up to whoever's writing the program. In NLP, in natural language processing, tokenizing is, it's a very important and like commonplace step that that's really used, and that's because it's really useful for just breaking down the text into meaningful little tidbits. So an example is like if we wanted to tokenize this sentence, I love this product, it's amazing. We could, one way to tokenize it is just by essentially split it by word, slash punctuation. So yeah, you can see these would be all the individual tokens that you can collect, just out of that sentence. Which, in essence, this kind of makes it easier for Python and the program to analyze patterns and sentiments and just the frequency of different phrases. It's also, it can make it easier to clean the data by filtering out punctuations or stop words. So like the word the or is, which kind of don't really hold like a ton of meaning behind them, in terms of like if you want to decide, if you're trying to figure out if it's a good review or a bad review, right? The word the and how many times that shows up, that's not really going to help you make that distinction. So words like that. Um, um, on the flip side, it tokenizing can help you identify these words that are a bit more kind of strong, such as, great, bad, amazing, horrible, tragic, stuff like that, which kind of give you like a better idea of the customer sentiment in a review. And a lot of this analysis is going to involve counting how many times certain words appear in reviews. Just kind of like, the whole point of this is we're trying to find ways to quantify kind of text data, and kind of, quantifying it helps put it into a format where both Python and us can kind of, draw conclusions from it. So now we're moving on to NLTK. So this is another kind of Python package / library, that is important in the NLP field. So NLTK stands for Natural Language Toolkit. And yeah, it has kind of like some even more in-depth functions that can help us analyze specifically this kind of data, these string files, string data types from things such as reviews. So we're just going to run this cell to import that library. So within here, there's a module. Within this module, there's a function called word tokenize that, you input a string such as a sentence or a review, and then it's going to tokenize it for you based on kind of the criteria that whoever programmed it, essentially like whoever wrote the code for this program set it up already. So we're going to just give you an example, a little demo of how this works. So you're going to have the word tokenize function, and then you can input this sentence right here. You're going to see it essentially splits it up. First off, the output is a list. It's in list form. And you're gonna see it splits everything up by individual word, except for the last character, which is a piece of punctuation. So that it considers, whoever wrote the program said we want to consider that as a separate token. So getting a little practice with this, task number 8 says use the word tokenize function to create an array called first review tokens array that essentially breaks the first review down into tokens. But it wants you to do that by referencing this array. So we're gonna call the word tokenize function, and then we're going to input the array of reviews lower that was mentioned in the instructions. But then you have to notice it says the first review specifically. So not all of them. Not all of them at once, because that would give you an error. Because this function only takes one. It doesn't take an array as input. It just takes a single string. So to do that, you have to reference. You have to use the item syntax. So within the list. So the way you do that is you add brackets to the end, and you say, since it's the first review, you're going to input 0. So what this means is you're taking the array of reviews lower, right? So wait, I can give you so you have array of reviews lower. This is a good way to just break down code into smaller pieces. Also, if you ever need help understanding or debugging. So taking this, you want to extract just the first review, right? And so for that, essentially the way a list is indexed is it's indexed by the items in the list. So this is the first item, this is the second, this is the third item. One thing that you do have to remember is when you're using this kind of index notation, the first item in the list is going to be referred to, is going to be 0 instead of 1. So essentially that's how you're going to pull that information. And then once you have that, you can see the output just breaks that down into the tokens as intended. Oops, what happened? View tokens array is not an array. Oh, okay. Yeah, so I forgot to turn it into an array. The output was still a list, and the autograder is looking for an array. So I'm just going to wrap this entire function into np.array. And there you have it. So if you wanted to kind of scale that, you could tokenize every review, and just use that to help you kind of further clean all the data at once, where you can remove all words such as the, is, all these stop words, all these useless words that don't really convey any sentiment. You can remove punctuation if you want. More advanced method is you can kind of reduce words to their base, to their root, it's a process called stemming, which essentially, it makes classifying, throwing words into the point is that you want to throw all these words into like different subcategories, right? And stemming makes the subcategories slightly bigger, so where you can see more of a pattern essentially between the data. So now we're just going to move on to sentiment analysis, just kind of another step up. So what's the word sentiment mean? It's kind of just the feeling, attitude, opinion, the general vibe, essentially. The emotion that's behind the review, right? So how does the reviewer really feel about this restaurant or this product in terms of customer reviews? So to kind of simplify, you could break it down into like positive, negative, and neutral. It's pretty unlikely that a review would be like 100% positive. Everything's a little bit nuanced. So yeah, it's probably going to be some kind of blend of, any given review is going to be kind of a blend of positive, negative, and neutral. So one common kind of NLP analysis task is you're going to perform sentiment analysis. So this code cell, you don't have to worry too much about it, but you're basically you're importing another kind of like program function from this NLTK library. And it's just something we're going to use on some of these reviews that we've been kind of just manipulating so far. So for example, like this review where it says love it, great sandwich. And so if you put that into the sentiment analysis or the sentiment intensity analyzer, this is what the output's going to be. So the negative, in terms of negativity, it's getting a score of 0, which means there's no negativity according to this program. The neutral score, 0.259. So some elements of neutrality, and then the positive score is 0.741, which is pretty, just looking at those numbers, you can see pretty overwhelmingly in favor of the positivity, which it makes sense, right? You have the word love, you have an exclamation point, you have great, and then you have like a heart emoji. So yeah, so essentially one of the things that this sentiment intensity analyzer is using is this Vader lexicon information, which is just it's kind of just it's essentially it's a bunch of information on a subjective belief of how positive, negative, and neutral a statement is. So it's just kind of like an extra kind of computation going on behind the scenes, and that's kind of how these scores are getting derived. So it's a pretty complex program, which is why we're not delving too deep into it. But I mean, it's important to understand kind of just that it's taking like slang, it's taking emojis into consideration, it's taking into consideration punctuation such as exclamation points and capitalization. It's taking all that into consideration. So that's just gives you an idea of kind of like, a few levels up, like how deep you can get in terms of analysis. So task 9, so we're just going to run these 2 commands on just comparing the first review, the raw data of the first review, and then the cleaned data, which is kind of like the data of the first review that we converted to lowercase. And we're just going to see how the sentiment intensity analyzer, we're going to just compare the 2 scores between them. All right. So I'm going to run these 2 cells. So you can see the original one, in comparison to the second one, you can see the original one had a slightly higher positive score, which makes a lot of sense, right? It's when we're putting it into lowercase, we're removing a little bit of the intensity, a little bit of the emotion, right? Because this program, as I mentioned above, it's taking into account it is case sensitive. Like it's taking into account the capitalization and kind of the emotion behind that, and that's what's leading to this original one having a slightly higher positive score than the second one. So yeah, why do you think the original version was more positive? The original review has capitalization, which conveys added emphasis and emotion to the review. Okay, now for the final task, we're just going to run this cell, and it's essentially going to give us the sentiment scores for all 3 reviews that we've dealt with so far in their original form. So you don't need to worry too much about this code cell. It's using one thing to note is it's using a for loop down here, which is it's essentially it's something you're going to learn about further in this course, and it's a very important part of programming in general. So I'm going to run this cell. It's going to give us a bunch of these sentiment outputs. So yeah, you can just take your time. You can look at them. For example, you can see like this one's negative, so the negativity score was way higher, and the compound score is a negative score instead of a positive one. Then this one's like a lot more neutral, right? It's just there's not really a ton of emotion conveyed. It just says it's a sandwich. So yeah, you can see like there's 0 for both positive and negative, and 1 for neutral, which kind of places it right in the middle of the spectrum. So the question here is, how did the sentiment analysis turn out? Do you agree with the results? Did it identify the negative reviews? Is there any cleaning you think should be done, or any improvements that, just off the top of your head, you think could be made to better capture some of the sentiments. So I'll give you a sec to think about that. Okay, so in general, it seems like it did a pretty good job, right? This one's negative, it had a negative score. One thing that it seems to have struggled with, or kind of like the key takeaway here, is this review right here, right? It's kind of it's using sarcasm, right? It says loved it, three dots, and then this eye roll emoji, right? But clearly the program thinks that, the program's not well versed in sarcasm, apparently. So it's saying that it's still analyzing it in a way that it thinks it's a positive statement, right? Because the whole point of sarcasm is you're saying one thing but you mean the other. Computer Python does not understand that, so it's giving this a positive score. And I guess that's just one kind of limitation of this program is yeah, it's limited in kind of like it's not well versed in sarcasm, like I said. And maybe it's not really thinking, it's not like something that could be improved upon, is or even just kind of something to think about, I guess, is it's how is it analyzing this ellipsis, these three dots. Because like us as humans, we know that can kind of be used to convey sarcasm. um Same thing with this emoji, but we're not really sure how this sentiment analyzer is intaking this information. So I'll just do a quick summary of that here. For the most part, the SIA, Sentiment Intensity Analyzer, does a good job. One thing to note is that it does not seem to catch the sarcasm in second to last review. Just say it would be interesting to know how the program is analyzing the ellipses and the eye rolling emoji. Okay, so that kind of brings us to the end. In terms of reflection, things to remember is, Python is this concept of kind of object-oriented programming, which is kind of the centerpiece for Python. And this kind of concept that everything is an object allows us to use these attributes and methods on stuff. The dot notation is something that's very important, and something I'm going to be using a lot in this class. And then just kind of this concept of cleaning data. So in this case study, we used the dot lower function, which kind of helped us standardize some of the data. Um, but then it also, on the flip side, it also kind of it kind of stripped away some of the emotion from some of those reviews, when we were kind of using the when we were calculating the sentiment analysis. Having them all in lowercase kind of maybe was a detriment because it removed some of the emphasis. But when we were trying to count some of the words and how many times they appeared, it was a positive. So yeah, just something to keep in mind. There's always a trade-off with using some of these methods. And yeah, we also just we did a little introduction to NumPy and the arrays, which is, can't stress this enough. The arrays are going to be like super crucial in this class, and it's something that's going to be used this whole semester. And yeah, kind of their utility in terms of batch processing. So applying, uh, manipulating like this group, these different elements all at once, which is what we're calling batch processing, which is much more efficient. And then yeah, we just brushed on this kind of natural language processing, NLTK, and these concepts like tokenization and sentiment analysis, which are a little more advanced, but yeah, it just gives you kind of a practical glimpse into some more complex stuff, and like maybe something you'll encounter if you keep following down this path. So yeah, that kind of brings us to the end. Appreciate you tuning in, and yeah, I hope to see you guys next week or in class as well. Um, so yeah, until next time, thank you.